Hello guys, welcome with Cisco with Aman Soni, and in today's lecture we are going to talk about static routing and default routing. Before continuing with the today's lecture, you have to have a prerequisite in front of you. So you have to be first of all know the basics of Cisco Packet Tracer. Why so? Because we are going to talk about static routing in the Cisco Packet Tracer. So first of all, you have to be familiar with the Cisco Packet Tracer tool. So this is the link. You can just click here and go to the Cisco Packet Tracer, and then you have to be familiar with the CLI modes of the router, because we are obviously going to do static routing and default routing on the routers only. So this video is also a prerequisite. If you know already, it's all fine. If you don't know, go back, watch the video and come back. The third thing, you have to have knowledge of OSI model. If you know a little bit about OSI, it's okay, you can still get along with static routing and default routing, but I strongly recommend that you have to have very good knowledge of OSI model. So this is a very in-depth video, almost 1 hour long, so you have to go through this. If you know a little bit OSI, it's fine. If you don't know, watch the static routing, default routing, go back, and whenever you are free, go through this video for sure. And obviously you have to have basic understanding of IP addressing, subnet mask, network ID, all these things. So for that, this video is here to help you. So you can go through this video if you haven't watched this yet. So let's begin without further delay, the static routing and default routing. Before even first continuing with the static routing and default routing, I would like to ask you guys, what actually is routing? What do you mean by routing? So first let me give you the technical definition. Routing is actually, it happens when you forward the traffic from one network to another network. And let's go deep into that. First of all, there have to be more than one network for it to have to be routing. If I have a switch and I have few devices connected with a switch, 5 PCs, and I want to do some LAN gaming for the night, and I connect them with the switch, so they will be doing the LAN gaming, they can do the chatting, they can do some file sharing, but is it routing actually? Let me show you what I am talking about. This is a packet tracer. So what we did, I just bought a switch. It don't have to be necessarily a Cisco switch. I can get a cheap one also. So I have my 3-4 friends and we just connected our laptop slash PCs, it can be whatever you like, and we connect them with the switch. And what we are doing, we want to do some data sharing, some movies, some files we want to share, and obviously we are going to have some IP addresses obviously. So we are going to have, let's say 192.168.1.1, the default subnet mask. That's why you need to have basic understanding of IP addressing. 1.2, 192.168.1.3. So I assign these IP addresses, and they just started doing some file transfer, some LAN gaming, some Counter-Strike. So you guys tell me, is it routing? What do you think? It is not routing, my friends, because it is just your common network communication. Why so? Because this is only one network. Why so? You can have 3 devices, I have 4 devices. Why it is not routing? Because you don't have a layer 3 device. What do you mean by layer 3 device? That's why you have to know the OSI model. Layer 3 is the network layer. If you have a network layer device, only the network layer device have the capability to divide the network. For example, a router. For example, a firewall. A router and a firewall are layer 3 devices and they can divide your network. Switch, on the other hand, is a layer 2 device. Switch do not create different networks. What it is used to connect a lot of devices to create a network. If you want to create a network, switch is the thing for you. If you want to connect multiple networks together, you have to have a router in front of you. So this is one network. And what is the network ID of this network, my friends? First of all, you have to know what is the network ID. So all the details I'm going to write down here. What is a network ID? A network ID is the name of the network. As simple as that. It is the name of the network. So, is it like network A, network B, network C, my network, my Cisco network, my gaming network? No, it's not like that. Network ID will always be in the format of IP address, A.B.C.D. I'm going to give you a lot of examples here as well. This is the network ID. This is the network ID also. This is the network ID also. Now IP addresses, whenever I tell, and the network ID as well, I have to give the subnet mask. I can't just say, okay, these are your network IDs. So with that, I have to give an appropriate subnet mask. For this is going to be subnet mask. For this little guy right here, this is going to be the subnet mask. This guy, this is the subnet mask. So you might be thinking, why only this? Why I am only giving 255.0.0.0? Can't I here just put it like this? Actually, you have to follow some standards. Meaning what? The classes of IP addresses. If you belong to class A, your network subnet mask have to be this. If you belong to class B, the subnet mask have to be like this. If you have to have class C, the subnet mask should be like this by default. But if you want, you can change it. Getting my point? If you want, you can change it. So this is a class C IP, and we are using the default subnet mask. So this is actually, my friend, is a class full network. Why? Because we are following the boundaries of the class. It is a class C IP, and for class C, we are supposed to use this. We are using this. So it is a class full network. What about this guy? This is a little bit naughty guy. Why? Because it is a class A IP. It was supposed to use 255.0.0.0. It was supposed to use this one, but it is using 255.255.0.0. So what is the big deal? The big deal is it will work, but it is a class less network. It is not following the boundaries of the class. Okay. What about this guy? It is a decent guy. It is a class A IP, and it is following the default subnet mask. So this is a class full network. Now, how do you calculate the network ID? This is the network ID. You know, class full, classless, subnet mask. Good enough. Now, we have in front of us IP addresses, not the network IDs, because we are going to go inside the PCs and assign this IP. 192.168.1.1. Default subnet mask, because it's a class C IP. We're going to go here, desktop IP 192.168.1.2. 192.168.1.3. Okay. So what are the network ID of this whole network? The network ID of the whole network is going to be decided by the subnet mask. So my subnet mask says the 3 octets are of network for all of them. Meaning what? 192.168.1. That is why you will be seeing 192.168.1 common in all the devices. So if somebody asks you what is the network ID, you can very easily calculate. The network ID is 192.168.1.0, because you are going to put the network part according to the subnet mask, and you are going to put a 0 at the end, and this is going to be your network ID. Perfect. Okay, so what I'm going to do now, I'm going to extend my network. Meaning what? I'm going to put a router here, and I'm going to connect my network to the router. And router is a layer 3 device, and it is used to connect multiple networks. So in here I have one whole network running 192.168.1.0, and in here as well, because it is a part of the network, on this interface we are going to have some IP from 192.168.1 network. Let's take 10. And for sake of some beauty, we are going to put this whole thing inside a logical box. Why so? Because it is one network. Now it is looking like a one whole network. This is a network ID right here, and the router, my friends, are the edge of your network. Why? Because router is going to be always at the edge of your network, because it is going to connect with multiple other networks. So now what? Now we are going to need one more network. Let's extend our networks. So we are going to have one more router, and we have one another. Now in this network, it is very small. It is so small, there's only one PC in that network. Yes, we can do that. And if we need only one network, then we don't even need to put a switch in here. Why did we put a switch in there? Because in this network we want more than one device. That's why we put a switch, because we cannot connect all the 3 devices with the router directly. Because if we connect all 3 of them directly to the router, it will not be a one network, but it will be 3 networks. Okay, go back, listen the line again. Okay, it is very very important you know the difference between the working of a router and a switch. Okay, now in here we have only one PC, so we need not have any switch. It is waste of resources, so we're going to just directly connect. In future if you need to have more than one device, then you have to put a layer 2 device or maybe layer 1 device. You can put a switch or you can even put a hub in here. They won't divide the network, it is still going to be one network. So now if somebody asks you how many networks we have in front of you, let's see. One network, our old one, we have one another network. In this we have only one PC, so we have to give them some naming convention. Let's give 192.168.2.0 for this network. The IP address is 192.168.2.1. let's take. Now, is it enough or do we have something missing right here? Links are also network, my friends. Always keep it in mind. What? This is one network, perfect. This is one network. What about this link over here? In between routers. In between routers, we also have one another network. So let's take some more color and put it in here. Okay, we have a colorful topology in front of us. And let's give 12.110.255.255.255.0. Now it is not necessary for this practical, but maybe when you go to the routing protocols, you need to know which networks in the topology are class full and which networks are classless. So you tell me, take a minute to think, which are class full and which are classless. This network right here, he is following the default subnet mask, so it is a class full network. His other guy right here also, he's also a class full network. He's using the default subnet mask which it was supposed to use, and this guy is not class full. It is a classless network. It is not using the default subnet mask. It was supposed to use 255.0.0.0, but it is using something else. Okay, so now in the packet tracer, one issue is there which I really don't like. If you using it by default, you will not see any interface. Actually it's good or bad, depends on you. If you just want to show the theoretical portion, the topology and the packet flow, it is good. We don't want to see a lot of stuff. But if you want to do the configuration, you have to know the interface numbers, which sadly we can't see right now. So what we're going to do, we're going to go to option, preference, and click right here. Show, always show port labels. If you want, you can do something extra also like this, the device name labels and model. We don't need them right now, we just need the port labels, that's it. A lot of interfaces, right? That's why it's not so neat now, but we need to know the interface number so that we can configure the IP addresses. So now the very first step, we have to create the topology, not physically like this. We have to put IP addresses everywhere. So let me tell you the IP addresses. We have 1.10 here, and these, my friend, these are the networks. Okay, this is the network. You can't assign this anywhere. If you try to assign this IP, you will get an error message immediately. In here we have 12.111, and in here let's give something else. See, the network part have to be same. 12.1.1 have to be there. After that we can put whatever. We can put 89, 98, whatever. But if you put 12.1.1.2, it will be easy for us to remember, easy for us to configure as well. Otherwise you'll be having some random IPs lying here and there. So let's go to our one and let's do the basic configuration. CLI, let's do a no, enable config t interface F00 IP address according to our topology 192.168.1.10 255.255.255.0. No shutdown to turn on the interface. Interface serial 20 IP address 12.111.255.255.255.0. No shutdown. Exit out. Exit. And just a precautionary thing, if you want, you can also give the host names. It will look very very good because we have more than one router and both are going to be router and router. So let's give this guy R1. IP addresses are already assigned. Show IP interface brief. Oh, my bad. Show IP interface brief. You have to be very careful with the spelling also, because if you don't, then you will be getting some error like that. Show IP interface brief, IP address F00 and 20. Now if you look carefully, the IP address 192.168.1.10, which is going to my LAN network. Okay, these two are my LAN networks. The IP going here is Status up and protocol up. Status up because I did a no shutdown. Protocol is up. Why? Because the other end the switch is on by default. But on the other side you can see the router side, the protocol is down because the other side, the router, the interface is down right now. It is shut down. Why? Because we haven't configured it yet. When you configure it, then only the protocol will become up. These are the small things that you should know along the way to your networking career. So let's go to R2 and the same thing with different IP addresses, of course. Enable config T hostname R2. Interface F00, IP address 192.168.2.1, 255.255.255.0, no shutdown. Interface serial 20, IP address 12.112, 255.255.255.0, no shutdown. Exit out, and now both sides are configured. So if you look carefully, show IP interface brief, you will look that after some time the protocol will become up. It should be up by now. Yep, it is. Sometime it takes few seconds, more realistic. And yes, there is a blackout. I hope the video lecture will be finished by then. No worries, let's keep up the good work. So now guys, now the real networking, the real routing begins. Now we have to move forward our packet from this network to this network. Can we do that? Let's check. Let's go here and try to ping the other side, but we haven't even configured this IP yet. This portion is remaining. So let's go to desktop, IP 192.168.2.1. we already have this IP somewhere. I think I assigned it here, 192.168.2.1 I have assigned. So let's use 2.10 here, no problem. And yes, good thing I did that, because if you try to assign the same IP address in packet tracer, something like this will happen. This IP is already in the network, because you cannot have the duplicate IP address, because then you won't be able to distinguish between the devices. Done. So now let's go here and try to ping 192.168.2.10. Let's see if it is successful or not. It will not be successful because it is some other network. It is not our network. That's why we are studying static routing. Request timeout. We can't succeed. Press Ctrl C to stop the ping. 192.168.1.1. Now this guy I can ping. Why? Because this is in our network, and this guy is going to be my default gateway. Why? Because this IP 1.1, okay, 1.1 myself, actually 1.10 in this case. Let's go there and try to ping the default gateway. Who is the default gateway? Default gateway is going to be the IP address in front of me to my layer 3 device, and most of the cases it will be a router or maybe a firewall. In our case we have a router, so this router is the default gateway for this whole network. First let's check, can we even reach it or not? You should be able to reach it. Why? Because this guy 192.168.1.10 is in your network. You have just a switch in between of you, and switch won't divide the network. It will create a network. So all of these three PCs, any device you connect in here have to have its default gateway set as 192.168.1.10. So let's go here and put the IP 192.168.1.10 on here as well, on all of them, on all the PCs. 192.168.1.2 we have here, 192.168.1.10, because default gateway means if I don't know where to send the data, I will just throw it to my default gateway. That's the use of default gateway. If you want to go outside your network, it is just like your gateway to your house. If you want to go to some other city, if you want to go to some other country, if you want to go to a pub across the street, the very first thing you are going to go outside your gate. That's why we call it default gateway. Okay, so now what we are going to do, we're going to check again. We have a default gateway, but can we go to the other network or not? The very good thing about networking, you don't need to take my word for it. I can just show you. I can reach my default gateway, but our aim for this whole video lecture is to go outside my network. 2.10 it was. It is showing destination host unreachable. It is very interesting if you look closely. Previously it was saying request timeout. Request timeout means I was sending the data to something. I want to go there, but nobody is responding to me. I don't know what to do. It is actually like that. But if you are saying destination host unreachable, it means somebody is telling to you that you can't go there. Meaning what? Now when you ping, the PC checked this IP is not in my network because I am 192.168.1. This is some other network. So I have to use a powerful tool which I have, which is my default gateway. So I will throw the data from this PC to my default gateway right here to 192.168.1.10. Now it all depends on this router. If this router knows the path, he will send the data. Now the router will do what? The router will look in the routing table. Show IP route. This is the routing table. Do I know the network or do I don't know the network? And let me tell you very important things about the router. A router only knows the networks which are directly connected to him. So R1 only knows this network right here and this network right here. Meaning what? R1 knows 12.110 and 192.168.1.0. Again, don't take my word for it. Just look here. It knows only these two networks, none other than that. So that's why the router, the default gateway, will send a message back to him saying what? I don't know the network. I don't know. Meaning what? The destination is unreachable, and that's why, my friends, you are seeing this message right here that the destination is unreachable because the default gateway is sending that message back to you. So now we're going to do static routing. And how do you do the static routing? You have to give a route for the networks that are not directly connected to you. So let me repeat, the networks which are not directly connected to you. So R1 have these two directly connected to him. That's why they are in the routing table. They are right here, but one network is not in here. Which one? 192.168.2.0, because it is not directly connected. So that's why we have to give a static route for 192.168.2.0 because it is not directly connected to me. Same way, I have to give one static route for 192.168.1.0 because for the same thing will happen if we ping from the other side. This network is not connected with R2. So the question is, how are we going to give the static route? Let me just show you the syntax for that. First of all, you have to be in the configuration mode. And as soon as you give the static route properly, it will pop up in the routing table with an entry of S because S means static, and it will be something like this: IP route. I want to give a static route for a network. What network? Then give the network ID. Mark my words very carefully. Network ID. I cannot put here 2.10 that if you want to go to 2.10 or 2.11 or 2.12 because there can be hundreds of IP addresses. No, I will say if you want to go to this particular network only. I can't give the particular IPs because if it would have been like that, my routing table is going to be huge. Then I have to give the routing entry for all the PCs. No, you will give the entry for a whole network, not for the IPs. If you want to reach to 192.168.2.0, 255.255.255.0, the subnet mask of the destination network, just throw the data to this IP. Now, what IP? To the next hop IP. You have to give the next hop IP to which you will throw the data. Let me tell you what it means. Just think of a kangaroo. Why? Because kangaroos hop. So we have to hop here as well. So if we are sitting right here and if we want to go to this network, what you will do? You will just hop the data like this. You will throw the data to him because this is the next hop. Listen carefully, you have only two next hop, one in this direction and one in this direction. Obviously this one we don't want to go because this is our home network. If we want to go, we cannot throw the data directly to this IP. So this IP will not be our next hop. Why? Because it is not directly connected to us. We don't even know. Okay, getting my point. The next hop IP have to be directly connected to you. So 12.1.1 something or 192.168.1 dot something in this direction. So just think of a kangaroo sitting here and the next hop it will take will be this. So this guy right here 12.1.1.2 is going to be your next hop if you want to throw the data to this destination network. So let me just put that next hop IP 12.1.1.2. This is my next hop. So let's read this in English. If you want to do routing to the network 192.168.2.0 with subnet mask 255.255.255.250, send the data to the next hop IP 12.1.1.2. Okay, so let me tell you another option too, which is actually not that preferable. But instead of the next hop IP, you can also give your exit interface here. You can also say, I want to send the data out my exit interface serial 20. But it is not recommended because of some proxy R problem. That is the advanced topic. That's why I just want you to skip it, but always keep in mind that you will be giving next hop IP, but apart from that you have an option to give the exit interface as well. Now exit, and to confirm the route, just do show IP route and you will see a new entry popping up in the routing table. If you want to go to this network, the next hop IP is 12.1.1.2. And what is this one? This one is the administrative distance of static routing. Okay, as we go into the protocols, all the protocols or the routing techniques have some AD values, and AD value means the reliability. The lower the value of the AD, the more reliable the routing technique is. Administrative distance values for various routing techniques. We have static routing, we have RIP protocol, EIGRP, OSPF. For static, it is 1. For RIP, it is 120. For EIGRP, it is 90. And 170 for some special cases. OSPF 1110. So now you know which is the most reliable technique, static routing, among all these. Why so? Because all these three are dynamic routing protocols, and static routing is the one that you will be doing manually with your own hands. So the same thing that you guys did here on R1, you have to do the same thing similar on R2. Meaning what? You have to give a static route on R2. Right now what will happen? The data will go from the PC to the router. Router will throw it to here, and he will send the data to PC, and the PC will send back. Why? Because PC have a default gateway. But now this router don't know the path to 192.168.1.0 network. If you are confused a little bit, don't be, I'm here for you and I'll be showing you step by step. So now what will happen when you ping, take my word for it, the data will go here. If I ping from this PC right here to this PC. Now we gave a route. If you want to go to 192.168.2.0 network, throw the data here. He will throw it here. Okay, this PC already knows this network, it is directly connected. He will throw it here. Now we have to send the data back to 192.168.1.1 because he was in the source IP. So he will send the data back because we gave the default gateway. He will just throw the data blindly to the default gateway. And now the same problem. In here we don't have the static route for 192.168.1.0 network, so our ping ultimately will fail, because for ping to be successful, this packet have to come all the way back home. If you just want the proof of this hypothesis, let's do the ping. 192.168.2.10. It will be failing out. See, same thing. Because in here the route is missing, so let's go here and give a route. Config T IP route. Now in this R2 we want to give the network the pathway to this network, the subnet mask of the destination network, and if we want to go to this network and we are sitting on R2, what is going to be my next hop? My next hop is going to be this IP 12.1.1.1, because from this, think of a kangaroo, it will be hopping in this way only. So 12.1.1.1. Exit out, proof, show IP route will be the routing table. We had a new static route, same thing. For this network, the AD value is 1 via 12.1.1.1, our next hop. So now the whole picture is there. Routing, and if you want to even confirm, and if you don't see the routes are here something, then go do this command and just check all the interface have to be up and running. It have to be like that only. Okay, so both sides have the routes. Now our routing should happen. Let's see, go to the PC, try to ping the other guy, and see, voila, it is pinging. So this, my friends, was the concept of static routing. If you want, you can watch this video 2 times or take notes or whatever you feel like it, because static routing is the core basic of your routing topologies, because we have static and dynamic routing. Dynamic routing is very different, but you have to be very strong in static routing. Why? Because it will teach you how the packet will flow, how the routing table looks like, what are the routes to give, what is the AD values, how the interface looks like, and all these things. So I hope you enjoyed this video. Now tune into the channel. Very soon I will be posting the video on default routing. But my friends, for default routing you have to be wonderfully good in the static routing concepts. So Aman Soni signing out. Hope to see you soon in the next video.